When Newton came up with his second law, he actually didn't write the sum of the forces equals mass times acceleration. He instead looked in terms of the momentum of the object. And what he said was that if you apply a force for a period of time, you would have a change in momentum. Well, if we looked at this, remember the delta just means that's going to be the final momentum minus the initial momentum. So I'm going to have P final minus P initial. And I know that momentum equals mv. And for almost all cases, the mass of the object is going to stay the same. The velocity is going to be what's changing. So what I could do is I could come over here and I could factor out the mass, which is going to give me change in velocity, v final minus v initial. And if I divide both sides by time, that gives me change in velocity divided by time, which we know equals acceleration. So in his documents, he doesn't write F equals ma. He actually looked in terms of the change in momentum of the object. And that change in momentum is called the impulse. If you are a safety design engineer for the auto industry, and if your job is to keep the occupants safe, this is the relationship that's going to guide you. The impulse equals the force applied over a period of time, which is going to give you a change in momentum. Now, this is going to be one quantity that it actually doesn't have a letter associated with it. We just simply write out that equals the impulse. The impulse equals the force applied for a period of time, or it equals the change in momentum. Now, in this case, if you were that safety engineer, you can't affect the mass of the occupant. You can't affect how fast they're going. So the entire right side of this equation, you can't control. So that's why you need to focus over here on the force times time. And what you want to do is, by making the time as long as possible, that will allow you to make the force acting on the occupant smaller. And that's why it's so important to wear a seatbelt, and for airbags, what the seatbelt does and the airbags do, what they do is they make the time that the occupant's coming to rest much longer, which then impacts the force, making the force much smaller. All right, have you ever heard of the phrase for a coach to say swing through? So what you're doing there is you're applying your force for a longer period of time, causing a bigger change in momentum, causing the baseball to go farther. All right, so let's do this question. So what we have here is we have a baseball, and the mass of our baseball is 0.14 kilograms. And we know that the pitcher throws it, so the velocity, the initial velocity is coming this way towards the batter, and let's say that it has a velocity of 40 meters per second. And then the batter hits it back. So let's say he hits it straight back with a velocity of 46 meters per second. Momentum is a vector, so direction counts. So let's go ahead and solve for part A. And for part A, it says, what is the initial momentum? Well, to find the initial momentum, I would need the mass times the initial velocity. Well, the mass was 0.14 kilograms. The initial velocity was 40. And that's going to give me a momentum of 5.6 kilograms meters per second. Now for part B, it says, what is the final momentum? And the final momentum is simply going to be the mass times the final velocity. Well, the mass of the baseball is still 0.14. However, this baseball is coming back in the opposite direction, and anytime we have a direction that's opposite for a vector, we have to include a negative sign. So that's actually going to be negative 46 meters per second, which gives me a momentum of negative 6.44 kilograms meters per second. For part C, it says, what is the change in momentum? And the change in momentum is going to be the final momentum minus the initial momentum, which is going to be negative 6.44 minus the initial momentum, which is 5.6. So in fact, instead of subtracting those two values, you're actually summing them up, giving us a negative 12.0 kilograms meters per second. Now the negative just means that this ball now is going to the left, which we've given a negative sign. But notice that it's not the difference between the 5.66 and 6.44. We actually had to sum them up because of those because of the signs. Now for part D, it says find the impulse exerted. Well, remember, the change in momentum equals the impulse. That means that that ball experienced an impulse of negative 12.0 kilograms meters per second. Now for part E, it says what's the impulse exerted on the bat? Well, the bat, this is going to experience Newton's third law. So the change in momentum of the bat is going to be equal but opposite from the ball. So that means it's going to experience a change or an impulse of 12.0, positive 12.0. For every action, there's an equal and opposite reaction. Finally, for part F, it says if it occurs in a time of 0.012 seconds, what's the average force? Well, now I'm going to use the relationship that the force times time equals my change in momentum. So the force times the time, which is 0.012 seconds, equals the change in momentum, which is negative 12. That means that that bat is exerting a force of negative 1,000 newtons. And it's negative because that bat is pushing that ball to the left. All right, you've been introduced to impulse. Good luck, and we'll see you next time.